Hey guys, I'm getting ready to do a quick spec build. We had some local guys that wanted to get together a spec quad, basically some cheap kit that we could implement that anyone can afford and have a high performance quad that kind of made everyone more neck and neck. I mean, the idea is to kind of bring in some of the people that have never flown quads before into something that's cheap but works really well. We're going to do a lot of interesting things in our local class and maybe hopefully get some other clubs on board so we can have some regionals or whatever else. I know there's 3 different groups in Arizona that are in the Phoenix area that do racing, and they all are on board. So hopefully we'll take this and make it something much more exciting and make it more of a spec class, where it's an open standard. I mean, it's not just going to be Raceflight. Other people can fit the specs and use some of these components with some of the components they like, but we're making basically a kit cheap enough where it's kind of a no-brainer to buy it because it's some pretty high-quality parts. As you can see right here, this is what the kit's gonna come with. It's basically, let me add one more thing here. It's $225, and it comes with almost everything you need besides battery and receivers, and we're going to have cheap battery packs. The reason we selected 3-inch is because they're way more durable, and they're just as high performance as 5-inch. I mean, I've seen Sean, beat his lap times on 5 inches with 3-inch quads on pretty wide open courses, so it's not even about a tight course. It turns sharper. Its high speed is slightly slower than a 5-inch, but it's easier to fly. It's less quad to actually hit a gate. It's super smooth. Like you can crash this into cement because of the lack of weight. It's less likely to break, and really props and motors and batteries especially are super cheap for 3-inch stuff. So it's a lot less expense for someone getting into the hobby. I mean, you can, basically grab this kit with a cheap Spectrum DXE or a QX7 Tyrannus, and someone can get into this for easily less than $400 with every single thing and tons of batteries and everything they'd ever need. The other thing we're going to start doing is giving the clubs lots of extra parts so they can do their own replacement plans or sell the kits or sell the parts, and it can be an income stream for the local clubs, as well as parts are on site, so the racers don't have to have the expense of stocking extra parts themselves. They know they can be out there race, and if they break something, it's there to buy, or even buy for the replacement plan cheaply. If they damage the revolt or the millivolt or the spark as well. So this is what the kit basically entails. It has our new 4200 kV 1407 motors. It has the big deal frame that Brian designed. Right now we're putting the TBS VTX in there, and it has the Foxier mini camera in there. The cameras and the VTX may change. Right now, these are what we've all decided are the approved ones, and I think run cams are going to be fine too, and there probably other VTXs will approve as well. We just want to make sure everyone has good video that's running in the class, so we don't have a lot of video issues out there, and we want to make sure we have replacement parts on hand if they don't do it. I think right now we're pretty much saying these are the only motors approved, so that way it's a fair spec. There might be other motors we'll add in and improve if we can find similar motors for someone else. But the flight control is open, the ESC is open. There's going to be a minimum weight, which we'll decide after I do this build. But I think this is pretty exciting. I mean, everyone that's flown 3-inch just loves 3-inch, so it gives us a lot of options and a lot of things we can do. I think that about summarizes. I don't know if anyone has any questions before I go ahead and do a build. But this is the important part that's showing you what we're coming out with. These spec quads are actually available this week for the local guys. I think some of them going to be running them this Saturday, and then it'll be available, put on the website next week with this whole kit. So if you guys have any questions, let me know. I'm just going to do a build here, and you guys can tune out if you don't want to watch a boring build, but you can see how I build it and hopefully get some ideas from it. So hopefully, any of you racers out there, or any of you guys at your local club, start talking to your club and see if you can get them to run something like this. Because again, the main thing we want to do is get new people into this, and we know it's an expensive hobby, and they either buy some junk out there because they're trying to save money, and it's not reliable, and there's no parts locally, and there's nobody to support it. What's really nice about this is it's going to come with a tune. At the beginning of the race, actually, where we plan to flip a coin. It's going to be either 3-inch or 3-cell or 4-cell batteries. So the 3-cell batteries will really be head-to-head. The 4-cell will be a little more of a spread. So people showing up won't even know. We're going to provide the batteries at the actual races. So there's just going to be a bunch of chargers set up that automatically charge. We use the TBS ones. We use the balance connectors. So they'll pull a battery off the charger, go race, and then put them back on the charger when they're done. So people don't even have to worry about bringing batteries out to the spec races as well. And everyone's running the same batteries. So, you could buy a couple batteries just for yourself to practice, and if you beat them to crap, it doesn't matter because we're going to make sure we always have really good batteries available. And when people go to race, they're going to pay a small fee to do the race, and that really goes towards the battery bank, so everyone has batteries at the race. So if you guys have any questions about it, I'm going to keep an eye on the text. Just go ahead and ask me, and I'll answer them. But in the meantime, I'm going to go and start doing the build. The prop are actually going to use the HQ. I think they're 30 props or something like that. They're really durable, and they work really well with these motors. Yeah, we'll have some units out the race tomorrow. We're going to be running them. All right, so one thing I want to show you here is this is our Spark ESC. It works just as is on a 3-inch. It's probably, you don't really need to do this next trick I'm going to show you, but we're using these in 5 inches with our 2205 motors on the new twig frame to get ultralight builds. And one thing we do to make it handle the power, because as it is, you'll blow it up on 2205 motors if you don't do this modification. But it's really simple to do. Basically, let me change my temperature of my soldering iron. So I'm soldering at 800 degrees. I usually use between 750 and 800. I take our solder and I run a trail of solder on this bar right here. So what this is it's the full power rail. In fact, I think I'm going to raise the temperature a little here. Because the soldering iron seems like it's running a little colder than it should be. Usually I can do this at 750, no problem. But I think this soldering iron has an issue. In fact, give me a second. I'm going to switch out the soldering iron for a better one. All right, Preston's running to get me another one of another soldering iron. So in the meantime, I'll put the motors on. Looks like the group live stream dropped off, so I put it back online. Okay, so one thing I was saying, one thing to do on the Spark to make it handle more power. This isn't required on the 3-inch, but on the 5-inch I recommend it. Is you take this eye right here is the full voltage rail, and you can take it and you can put more solder on it. And basically what that does is it gives it more of a a thicker conductor, so it can handle more power. So you want to run a snake of solder down the whole rail in all directions. And if you do this, it can easily handle the 2205 motors we sell for your ultra lightweight skinny kid or twig builds. We even run it right to the pad. I make a joint together. Like one bit. So what I'm doing is just giving the electricity a thicker path to flow on, because you just gotta think of wire as like your highway, and the thicker the wire, the more cars, the more lanes you have on your highway, so the more power everything has to transmit. So while I'm tinning, I'm going to tin the negative. Now I know you guys have a hard time soldering this. Just use plenty of heat, hold it on there. Our grounds are really thick and big, so it takes a little bit of heat to do it, but if you just are a little bit patient, it should tin just fine. So next I will tin the other pads. To solder this up, you just need one ground, and all the rest, all the circles are non-grounds. So I'll tin all the circles, and the squares are the ground. I prefer to use, there are all the circles. So basically either this ground or this ground works fine, because it's out of line. So I'll just use the end ground. And that's all you need to do for that. Then what I typically do is I have really long wire on these motors, never use them. So I'll take this motor wire, and I'll use these to put it together with. So it looks like I need 3 and then 4, so 7. So I'll take 7 of these. Don't need those 2. And I'll tin the other end. So just take them all, twist the other end when you strip it. These wires are probably a little longer than I need them to be, but too long is probably better than too short. Just make sure you see how I'm twisting them after I strip them. That keeps those stray hairs from popping up when you're soldering and causing havoc on your builds. So the easiest way is just to lean these against something. Then tin each one. Put a bunch of solder on your tip, and then run them into there. Don't worry about getting too much solder on your tip. If you get too much, just brush it off, but you're gonna waste some solder tinning these. It's the easiest way. Just make sure they get lots of solder on them. Now it's a good idea. The other end comes pre-tinned, but the tinning is usually not that great. So it's sometimes worth just tinning it again. So it looks like I missed this one. Sometimes they're up enough you can do it, but I don't really like to do this because it damages my mat. Somehow I missed a couple. All right, now another trick is once you do this, trim it so there's only just a little bit on each end. If your end's too big, you're more likely to short. So you want just a teeny bit on each end, just as much as you need. To get on your pad. This is how you do a nice clean build. You want, not too much wire, not too much solder. The more you have, the more likely you are to have a short. So trim those things really short. It shouldn't even be any longer than the pad. If it's longer than the pad, then it's too long. Okay, those are all ready. Now let's get our wires ready for the battery connector. So these we're gonna strip them. Same thing, lean them against something. Lots of solder. It's important you really put a bunch of solder on these so there's no stray hairs. Again, once I make it, I'll shorten it up a little to be the size I want it to be. All right, now I'll flip this over. I believe on these builds, I like to go on the edge. So just make sure this positive is pretty short, so it doesn't go onto any of the other pads. Usually what I'll do for this is I'll put it right on the side here like this. Gotta give it some good heat. Remember, our negative is the one that needs the most heat. Hold it there. Hopefully don't burn your fingers. I don't know if you can see that. It's all the way on the side of this pad. Then what I'll do is put the positive all the way on this side. Give it plenty of heat. And there you go. Now these wires are nice and flush coming out the side. That's exactly how I want it. Yank on them real good. Just make sure it's a real good solder connection. And there you go. Now that one's all ready to put in the quad. So we'll go ahead and put it in here. And we want to put, the power wires to the bottom here, like so. I'm going to actually put the capacitor on this end instead of this end. Makes it a little easier, so we're not going to worry about that right now. So now we're going to put these little wires on these pads. Let's make sure we have a good amount of solder on each one again. Not the just has a little ball of solder on each. Okay, looks pretty good. Now we're gonna just put our things. The best way is always to heat from the wire down. Sometimes you have to touch the pad. Usually you let the heat transfer through the wire. That way the board doesn't get too hot. You're gonna know if that wire gets too hot because you're holding it. So you're not gonna do any damage heating it through the wire, because that wire heats up and burns your hand. You're holding it too long. See, I can see I did a short there. Make sure you use your eyes. There we go. That's nice. Okay, so now that we did that, we're going to put the board on it. We need to make sure that we line it up properly. So it goes like this. The way I can tell is the two round pads. It doesn't have one round pad in here, so I know it lines up like that. So I'm going to solder the same ones here. That way I don't make any mistakes when I go to put it on there. Hey Preston, bring me a set of tweezers. All right, there we go. I'm gonna put the motors on now. Preston's gonna grab me a set of tweezers. But as you can see, that's a nice short stack. That's pretty good. Now you can, I think this is probably a good way to go. I'll put the motors on. Thanks. got some tweezers. I'll put these on. Tweezers are making it harder. All right, looking good. Why does he say? There you go, Brian. Hopefully that'll help you see a little better. Alrighty. So now what I like to do is take some wire here, or take some tape. I usually tape the motor wires as close to the edge as I can. Okay, once I do that, then I can figure out the length of the wires. That I need. That one looks like it needs to be about there. Okay, and then the next one goes to the next pad. So about there. And then the next one to the next pad. So about there. Just kind of run them where I think they're going to go. You know, a little too long is probably better than too short. I think that one was way too long. All right, that's much better. now do the same thing to tin the end of the wires. Try not to tin the wires over top the board, because if it falls, which solder definitely likes to fall, it'll fall onto the board. If you saw my other live stream, you saw make sure you use Kester solder. You can't really tell it says Kester, but you can see it doesn't like to splatter and go places, and it melts real easily. Just makes it for a way more enjoyable build. All right, those are all ready. Now I'm going to tin these pads. Now when tinning these pads, you want to see gold on them when you're done. If there's not gold on them, you put way too much solder. Tin from the sides, go in like so. Just put the heat to the sides, put the solder more on top, and there you go. The reason I'm doing it from the sides is I know I'm not getting it on the FETs. I don't want to damage those FETs. Sometimes with solder, it's good to even make 2 passes. Where, see, I'm tinning them all right now. And then, if I see I need a little bit more solder, I may go back and do them. Because once the solder gets once the pads get really hot, it's a little harder to control your solder. It wants to flow places instead of build up. So this one I'm putting a little bit more on the top. But as you can, hopefully you guys can see. I don't know, maybe I can give you a better look. But I don't know if you can really see, but there's gold still on the inside. I'm just putting it on the outside. So once I get that, I just start putting my wires in their place. I kind of like to hold it on the side. Heat through the wire, remember? Hold it in place and let go. This one I'm curving around a little bit. Prevent a short. There we go. Now you might need to trim these. Just make sure they're not touching and there's no wires touching. It's probably a good idea to have some sort of magnifying glass or something when you're doing this, just to make sure nothing's touching. And actually it does look like this could be touching a little, so I'm just going to take this off. I'm going to trim these down a little. I think I made them a little too long. You know, most likely when you're doing this, you're not making them the right length when you first strip them, because you're not, you know, it's hard to strip exactly the right length because the coating bends a little bit when you go to strip it, so it stretches sometimes. There you go, that looks a little better. So now, hopefully I'll keep it from shorting. I think on these I prefer to come back this way, now come to think of it. I think I might have made them a little too short. That's what I'm saying. Too long is always better than too short. It's not a big deal. I'll just come from the outside on this one. Okay. I'll leave home room for my standoff. At this point, maybe it's a good idea to just put my standoffs on, just to make sure the wires are clearing them. There we go. Next time I think I'd make it a little bit longer so I can go on the inside, but what's done is done. Alrighty, this last one's now. Alrighty, that's good enough. Now we can take camera mounts. grabbed 2 of the wrong ones. I get the knife. All right, now I guess I might as well do the capacitor. So I want the battery connector to come out to right about here. So I'm going to use the rest of this wire to mount the capacitor. Trick to this is lots of solder on this wire. You can leave a ball of solder on there, it's pretty good. Take my capacitor, make the wire kind of short on it. And then all I have to do is hold the wire to it. Heat the wire, not the capacitor wire. And then try and apply heat to the capacitor wire at the same time and just completely cover that with solder. So I just put that on the wrong side. That was a mistake. We'll do it on this side. Looks pretty good. Make sure you do positive on positive and negative on negative. Okay, now that you've done that, get some shrink tubing. Yeah, Dirk, you can. It's going to be on our website soon. You probably missed the beginning of the stream, but basically we're trying to roll out a spec class for local clubs where they can make money, and we have some interesting things coming. We'll put more information on the website. We're rolling it out today locally and trying to roll it out everywhere else pretty quickly after that. All right, there we go. Put some shrink tubing on there to protect that. So now we need to figure out how exactly we want to mount this capacitor. I mean, sometimes I put them on the arms, sometimes I put them at the battery. I think I'm just gonna cut this one with a long enough wire that I can, decide where I want to put it. So strip this wire back further this time. Kind of want to fan it out. And then you do the same thing on this side. Kind of fan it out. Now we're going to kind of try and push these together. Line up the base of them. And then twist them really tight. As tight as possible. And then once we do that, we're going to tin it real well. When your tin and 2 wires together, you heat from underneath. When you can feed solder in, it melts from the top. You know it's really well tinned together. Same thing on the other side. Fan them out. Probably better if you fan it out like this. Okay, and then put the 2 ends together. And then twist as much as you can. Okay, now we did that, we're going to cut this a little shorter. And that gives us something to put on this XT60. Now the only problem with doing it this way is we might not have big enough or good a size shrink tubing to put over, but let's see what we have. I think this should work actually. Hey Luke, what's up? Need to get you one of these, Luke. Want me to send you one, Luke? If you guys don't know who Luke Bannister is, he's probably one of the fastest racers on the planet. He's also the biggest troll on the planet, so. A little shorter, I think. All right, there we go, cool. All right, got that on there. Now what I'll do is tin this. Huh. Well, the camera seems to die. Let's see why. Doesn't really seem like it got too hot. I don't think it's. Well, maybe should give me another battery. It's not fully charged. What's that? I charged some. There should be the black suitcase. Okay. Well, hopefully this camera will hold out. Might have lost some signal. So, same thing here. Tin from the wire into the connector. This one we're going to try not get as hot because it'll melt the shrink tubing if you get it too hot. That actually looks pretty decent. No, I mean for the little camera.
I know, I'm saying there's not correct ones in there.
Kind of a pain to do the capacitors this way, but I did get it on it. One trick I like to do is if there's bare wire like this, you can't get the shrink tube over them, which I may have heated the shrink tubing up too much. Yeah, looks like I kind of did. Is I'll use hot glue to fill it in.
Hey.
All right, so that's pretty good. I think that'll work pretty good. We can plug the batteries in like this, keep them out of the way. I might even just tape it to the side like that. I don't know, I'll figure it out once we put it all together. We're gonna get some hot glue to fill this in so it doesn't short out. It's a nice trick, it works pretty well. But that way you can have the capacitors going from there. It might have been better. This is the first time I try it this way. I probably end up doing it from the pad next time because that's how I usually do it. But it was a good thing to see if it worked. On the bigger connectors, it seems to work a little better than the small ones. Okay, we got some more of these camera connectors. Okay, so now we're gonna put the camera in there. Guessing it goes this way. Can I just plug it into something? There, put it through there, Preston. Just plug it in that way.
You have it plugged away.
Oh, okay, that's fine. Now if you crank this thing down, it'll hold into place just really good. So there we go. I think that's enough camera angle. Probably turn it up like this to get it going. Okay. All right, so next we need to put the cable in here. This side actually goes to the camera. Okay, there we go. So it looks like we have power, video, and I'm guessing that is full LiPo. I have to check. Let's see. This is a 3-inch actually. I dropped the camera. All right, guys, let's let it cool off for a second. Camera will be right back. Okay, camera came back. If it goes out again, I have another backup camera here I'll switch to. Never used this camera for such a long period of time, so I guess it's overheating. I'm gonna move one wire here. Put it around the standoff so that way the camera can go all the way down. You see the coating came off this wire here. I think I pinched it with the screw. So I'm actually gonna put a little hot glue on that too, just to make sure it doesn't short out anything. Plugging in my hot glue gun now. Okay, so let's figure out this part. Okay. Okay, so the thing we need to do is we need to get full lipo to this thing on the, and we're just gonna cut these wires. On the blue wire, and full lipo on, and the power wire we're just gonna put right to, these three wires we're just gonna put right to the TBS. So we're also going to power the TBS too, so we're going to go ahead and strip this back. And I'll take the TBS wire at the same time. And strip it back. We're going to twist both these together because they're both full lipo power. Okay, and then once we do that, and you know, you shouldn't do what I just did, which is tin it underneath the board. If you do, just be ultra careful. But we have a full lipo wire right here coming from the spark. So I'm going to hold those two wires together here with some tweezers. Really difficult. Okay, there we go, I think. So then once I do that, I can solder it. Ah, came apart. That was great. Let's try it again. So run cam without the OSD, this is real easy to do because I can actually cut the TBS connector and make it work perfectly. So this one makes it take a little longer. But we're going to have voltage on OSD, so that's a plus. Alright, you want to switch the camera?
Yeah.
Alright, Preston's going to switch the camera for us.
Yeah, it is kind of warm.
I think this camera just got a little too hot.
It's on the other side of the camera.
So give us 1 second for technical difficulties. When we turn on back on the video, we're going to be all done. You're like, hey.
This doesn't quite fit there, but hold on. It's in. Where's the menu button on this?
Just stripping some wires, guys. You sure that's not going to be way too zoomed in?
It's because it's in a different mode. There you go.
I can't see anything, but can you see if it's right?
Yeah, hold on. This doesn't quite fit in here like the other one does. There you go.
I think the quality looks worse on it.
I think because it has the profile on it.
Everyone's timing me. Now it's going to be extra slow.
So, focus. Where's the live on this one? Okay, well, they at least can see you now.
Oh, it's actually much better. So I just got to do it underneath the sticker.
Yeah, I just did right there in between the two.
Can we not
stickers.
make it so crooked?
You can fix that.
It's a little.
It's just kind of hard to adjust.
My OCD's on overdrive. Is it the best we can get it? Alright, guess that is it.
Actually, does look better.
Alright, guys, we got the more expensive camera. Let's hope this one works. Was using this little Sony. It works pretty good for most things. Does 4K in slow motion, but I guess it couldn't take the long-term heat. Now again, I can't stress enough, don't tin wires underneath the board. Even though you see me do it, don't do it. Put some masking tape over it or something. I've done a million of these, so I like living dangerously, and I do have a cabinet full of them if I screw up, but with you guys it sucks if you screw up. So put some masking tape over your board or something while you're doing this. Just do not tin your wires over the board. That solder likes to drop off. So now once you've got your things tinned, put a decent amount of wire on them. And we're going to join all these together. Same thing here. the longest part. We're trying to go more solder free with things, and the little build still has a little bit of solder. So we're gonna get some shrink tubing. Real skinny ones. Cut a few pieces down. We're almost done, guys. Okay, now we put shrink tube into the wire. You just kind of hold the two wires together, and they put heat on both. And make sure you can pull them. Get a nice, good, solid connection. Same thing. All right, here we go. We now should have video. Let's bring these suckers up, get them heated up. Ordinarily, I'd use a heat gun for this, but I'm not at my normal build table, so. So that already does work in a pinch. Okay, I think we're pretty good there. So now we have this ground, we need to connect it. We can connect it to any ground on the board, which we have a lot of spare ground, so we'll just pick one. All right, now we have our full harness. Then we need to solder that wire to Yeah, you're right. Okay. Okay, so that's pretty much it, except for installing the crossfire. We'll take this little TVS. I don't know. I think one thing I'm going to do. Well, here, let's hot glue this while we're waiting. So you can use hot glue for these connections when you don't have shrink tubing, and it actually works really well. The other thing I like to hot glue is put a little hot glue in here. Use it like a grommet. So you're kind of doing it like a 3D printer. So you need to put some on there, let it build up, put a little bit more, let it build up. And that'll let it won't kind of drip into the thing. Let me get these wires out of the way. Okay. So we're actually kind of making a grommet underneath here to keep the wire from kind of going through and like rubbing on the carbon essentially. I think we need a little bit right there too. That wire the coating was coming off of. So we're gonna put it right there just to make sure there's no short. I'm a big fan of hot glue. It really keeps things together and coming apart and shorting and doesn't add much weight. If you look at my quads, you probably see there's hot glue on them. I love hot glue. Probably to excess. So. But if you think of hot glue kind of like, I mean, it really works like a 3D printer. You can really kind of build it up and do what you want with it. And even in Arizona, it doesn't seem to melt or anything. Okay, so I don't know if you guys can tell, but basically where the wire comes through, I put hot glue in there. It just kind of keeps it in the middle of the hole so it doesn't rub on anything. Okay, and then once that hardens, we'll do some other stuff, but that should do it. Okay, so now we're going to take this TVS ones. One thing I like to do is we're going to try out, because we've had real good luck with them, and we're going to try a race tomorrow where a lot of us are using them, but we're going to pop this and put one of the TVS, I forget what you'd call them. I forget what they call them, but they're basically linear antenna that they sell. For now, I'm going to use some hot glue to keep it in place. Actually, what we usually do is we'll shrink tube them and put them in there, like so. Might even be able to shove it under here. Let's see. We usually put some shrink tubing and shove them under. Maybe Preston can grab me some shrink tubing. Why don't you go grab me some shrink tubing for this, Preston?
For the VTX?
Yeah. So we remove the TVS string tubing, and we replace it with another piece, and I'll show you. It's a good little trick. We love linears. We use them all the time. They work awesome. The right and left stuff never seems to matter for us, but everyone at IO, I saw lots of people running left-hand antennas with right-hand antennas and didn't even know. I know Gil ran one like all day and had no idea that he was running the wrong antenna. Alrighty. Okay, so now we're gonna flip this over and I'm gonna put a little hot glue on this side. There we go. Gonna hold it for a second and let it harden. Okay, I think that's pretty good. Oh, good, you got it. Good job. Can you plug it in over there? Is this the right size?
It's the only one that fits over here. It really needs to be a little smaller, but the strings.
I don't know. Apparently, you got me string tube in the size of, I don't know what, big enough to fit over the entire Earth twice. I think I need some scissors too. You can see here, this is the one we're using, and it's enormous. Andrew's saying it's called a whip antenna. You don't have scissors? Yeah. Yeah, this is good. Okay, let's put this over here like this. So the trick is you take your tweezers. And you try to hold it in place while you heat it. And again, we'll use my favorite thing, some hot glue. Stick some hot glue in there. And then I'll hold it down and heat it even more. Okay, now the trick is hold it till it cools. And we should have a pretty nice little VTX package. You can see. All right, perfect. Now the key to this 3-inch is light as possible, so that's what we're trying to do. We're trying to make it light as possible. The lighter it is, the better it flies. The smaller the quad, the more weight matters. The bigger the quad, the less weight matters. 5 inches, difference in weight, not as big a deal as a 3-inch and a difference in weight. So, now that we have this all ready to go, it's still a little wet, or a little whatever. Not dry, but should work, or heat it up, but. So now we'll take this. We're gonna put it on here. Now there's 2 ways to go. You can kind of put this on top, which you know we've done. So it goes like that. It's not as protected, but it kind of gives us easy to get to the VTX. It's one of the reasons we like to do it. Or you can put it underneath, essentially like this, and protect it pretty good. And it's backwards. Good. I'm glad I didn't put it on like that, like this. So it's up to you. And then I like to put the RX down on the back here. You can put the RX on top there. I mean, there's a variety of ways you can do it. I think for this build, we'll put the VTX underneath. Okay, so all we gotta do is plug in this sucker. And we're almost there. We're gonna do the smart audio next. Or not the smart audio, but the Crossfire. I'm doing this one with Crossfire just because I've started using it on a lot of things. It works really well. It's really long range. I don't think it's quite as less latency, especially further away, as Spectrum is. But I do like that we don't ever have an issue with anyone on the track or anything like that with it. I think I'm just going to put this Crossfire RX, like I said. I like to put it kind of back here. I don't know if you can see. I usually tape them on the back or something like this, actually. You can put it inside there. I just kind of don't like to have to push everything together. I just kind of like keep it out of the way. On the back there, it's pretty protected. Don't really have any issues with it there. So what we're going to do is we're going to take this Crossfire wires, and I'll show you how to wire up Crossfire. It's a little more difficult install just because it's a little more work to have to strip wires and stuff, but it's not a big deal. So if you have the big Crossfire or even the little Crossfire, channel 4, you want to go to your VTX. That's one of the reasons we like using the TBS ones. The VTX can actually control the VTX on the back of the radio if you have the big one, or through the Lua menus on Tyrannus. It's easy to change your channel, and that really matters when you're doing racing, because you want to easily be able to switch channels whenever they want you to, since you never know what heat you're going to be in. So take this, chop all the wires off the very end. Okay, so the first thing we're going to do is take channel 4 and we'll splice those wires together. Channel 4 is what controls your VTX. Same procedure as before, trim them both the same length. Put a little piece of shrink tubing on it. There you go, beautiful. Now we actually have a heat gun, so I guess I'll do it with a heat gun this time. Okay, so channel 1 should go on TX1, and channel 2 is TX3. If you want to look up I'm going to go to revoltfc.com, look at the pinouts, millivolt and spark, as you can see. So the TX3 is on the inside, it's the third, and TX1 is on the outside, the third one. So that's easy enough to put it on there. So we have no need for channel 3, so we're just going to chop that off. I don't know if it's for future use, I'm assuming. Okay, and channel 2 we're going to put on the inside one, which is RX3, or TX3 I mean. So let's strip it back and tin it. Alrighty, so let's get our pads ready over here. So ground, power, and so it's the third one. So we did intend channel 2, right? Actually, I kind of screwed up here. Let me go get another cable. Hey, press it. Okay, I'm not totally screwed because the Crossfire did come with another cable. I actually went in the wrong direction, so I thought I was on 4 and I was actually on a different one. So what I'm gonna do here, this is actually not too bad. So this one goes in here as well. Yep, so I just need to put 4 in there. It's not a big deal at all. It's pretty easy to do. So all you do is you lift up this little plastic part right here. And it should just pull out. There we go. Now I can take this. Thanks. Make sure it's the right sides up, which is the side. And just stick it in this other harness I had. There you go. Problem solved. Whew. Breathe easy. Okay. Now let's make sure we do this right again this time. Okay, so this one is channel 2. Okay, let's put channel 2 on it's on the inside pin for the 3rd. Okay, perfect. Now let's put TX1 on the outside is the 3rd one. Again, remember, do not tin over top of anything. You do not want solder falling onto your circuit board. You see lots of ones using the replacement plan, and that's what had happened. Okay, perfect. Okay, now we just need power and ground. These are 5 volts, so let's check out our little chart here. It looks like power 5 volt is on the outside, so there we go. So we're going to tin the outside pins. So the next one is the power. Okay, all we need is ground. Okay, there we go, perfect. So we'll take this one out to here, take this one over here. I'll put a temporary screw in here. Probably when I'm done with this build, I'm gonna get some zip ties and clean it all up. But the build is essentially done at this point. I just gotta, attach this. I'm gonna attach it here, or something like that, and put some zip ties on those wires to put them all together. But there we go. I don't know. Let's see what our timer says. So 1 hour, 45 or 52 minutes since we started this stream. We had some technical difficulties. But there you go. You can build a quad in less than 2 hours, which is really excellent. We're gonna make this a little better. It's an easy build for new people. I mean, it's not the easiest build, but it's decently easy. Let's test it. That's the only thing we haven't done yet. This is an important step. Nah, I know usually. Okay, so here's an important thing to do. This is called a smoke stopper. I recommend everyone build one. It will keep you from frying your stuff. One thing I do need is a adapter, since I'm using a big battery at the smoke stopper. Do you have? Where is that adapter, Preston?
You pulled it out. You pulled out the other stuff.
I did.
Yeah, it's right next to you over the ground. You just dropped it.
Drop the adapter. I did find it. So let's go. You go ahead and use it. Let's see. Put my tools in the drawer. Okay. So here's how a smoke stopper works. You have two. I think the red is the high power. The one is a lower power. I think we can get away with the lower power. You plug it into your quad. Okay, this will gonna keep you from frying any of your electronics. Then what happens is if there's an issue, it's going to light up. That means there's a short. If it doesn't light up, then we're probably good to go. But if there is a short, it's gonna keep it from being fried. There we go. It should light up when it's using power. So actually, I think we just don't have enough power. It sounded like it hung, so we're gonna go for the red one then. There we go. It's turned on, full power. The light bulb is off. You can see the lower power didn't work because basically the board just kind of freaked out, didn't have enough power. But we're plugged in with the higher power one and 0 lights. That means we have no shorts. We don't have to go hunt to figure out what the heck we did wrong. So there you go. That's your full build. If you have any questions, feel free to message me direct or ask them. This is the new quad. We're going to give some more information out. We're going to put it on our site and give other information and let everyone know what's going on and what we had in mind. Anyone have any questions before I close off the stream? There's a couple questions. Preston said there's a couple questions, so let's see.
Someone asked if it comes with the 3D printed camera mounts.
Yes, it does come with the 3D printed camera mounts.
And then someone asked how much it weighs with props and the battery.
The final weight I'll put on there, but it's without a battery, it's about 130. I think between 120 and 130 grams.
And then someone's asking for a good place to get shrink tubing.
And shrink tubing we usually get from Fry's Electronics, but you can also, the easiest place is probably Amazon. They make a kit that looks like this. I recommend you buy it. That has most of the sizes you need, and the big stuff you usually get like 3 feet at a time. Anything else, Preston?
Not really. Not that I see.
All right. Hopefully no one has any other questions, and let me know. Just go ahead and feel free to message me if you do have any.